Thank you. Can you hear me? Yes. Okay, because I can't hear myself. Okay, good. So welcome to this presentation. I think it's not going to be much of a new things, but what I'm trying to intending here is to remind you about what the mobile network brings on security features already built in for your potential IoT or machine-to-machine use cases. Yeah. Um, my name is Peter Gaspar, and I head the architecture team in the A1 Digital. A1 Digital is a sister company of the A1 Telecom in Austria, which is the incumbent telecom, and we basically cover the new technologies for the whole A1 group in the Central and Eastern Europe. What I mean by the new technologies, we run our own sovereign cloud called the Exascale. We take care of the managed connectivity mostly for the IoT solutions, so the IoT connectivity, that's the second point. We also help our customers with the IoT solutions themselves. So we have the capacity and the know-how to build an IoT solution end-to-end. So from the device all the way through the connectivity to the cloud and backend and to the presentation towards the customers' business users. So the complete end-to-end IoT solution. And we have a team concentrating on the security. So advising the customers about the security, doing the audits, helping with the pen testing and so on. So my area where I work are these 2 points. I had the architecture team that takes care of our portfolio for the managed connectivity, and that takes care of the customer solutions that we built. Good, but you can see that we have the experience in actually both these areas, so not only the connectivity itself, but because we basically eat our own dinner when we are building up the IoT solutions, we have had experience with many challenges that you may have in building the IoT solution, and combined with the security, that's what this talk should be about. Yeah? So what are these challenges that we meet when we talk to our customers who want to build an IoT project? So, and I really focus on the security in this talk, not on the other challenges. There's enough of them, and you probably, if you build the IoT solutions, you know about them. But generally, what we see is that there are very quick proof of concepts. So the people want to start something and show that something is working. And very often they put the security on the second priority. So in the proof of concept, just make it work. Yeah, just send some data, make sure that it works. What it means though is that in the proof of concept, you basically miss to consider all the other aspects that are then relevant and critical when you do the productization. So in the proof of concept, you basically do not calculate in what the future costs might be because you have missed out the security. The second problem that we see is the other way around, an over-engineering. So putting so much effort to secure the whole solution that by the end of the day, when you calculate the final cost of the solution, it doesn't fit, right? It is not viable from the financial side anymore because you have just over-engineered. And again, security is one of the things you can really over-engineer to eternity, yeah. And the next thing that we see is, again, maybe from the proof of concept, maybe from the initial phases, everything works fine. We're secure. We have a nice solution. We get the first data. It is what we were waiting for. But now we think about scaling. Now we need to bring into the field thousands of the devices, and the thousands of the devices can have a bug, right? Or there might be a security alert for one of the components that we are using. And now you have to have a certain framework built before so that you can handle this. So you have to build your security the way that it can grow with your solution. So how does the managed connectivity itself can help here or is relevant? So we need to look at the managed connectivity to maybe compensate for some things we cannot do on the device, because the devices might be constrained. Or we can basically use what is already there. So the network comes with built-in security features, and you cannot turn them off. Yeah? You cannot say, I'll do my own security, network, turn it off. You have to have these features enabled, and they will be there if you want or if you don't. Yeah? So use them instead of building something on top. And what is often forgotten, the mobile operators have their history of decades of handling the security on a very professional level. Yeah? So the networks, they serve not only our IoT use cases, they serve governmental organizations. Yeah? They serve military organizations. The security in the mobile network is, now I wouldn't say bulletproof, but almost, right? So I don't want to jinx it, but the mobile networks are one of the best infrastructures, best protected infrastructures that you can find. So use it, yeah? So let's try to use the mobile network to get the end-to-end protection with the minimal demands on our device, on our IoT solution. So let's reuse what's already there. And in this presentation, I would like to show you a one use case that we were analyzing, and it's about, you don't need to read it, I will tell you what it's about. So we have a customer that is renting these RVs, recreational vehicles, so basically caravans. And it's a seasonal business, so in the winter they have to store them somewhere. So they have a big, or they have a multiple parking lots, and they are a few square kilometers in the area, and sometimes they need to find the vehicle in the field. They don't need to know exactly where it is, they just need to know in which zone. So if they need to send a cleaners, or if they need to pick it up for the customer, they just need to know approximately which zone this RV is in. So, and they thought, let's use some IoT for that, right? That's a perfect example. So, but what were the requirements then when we broke them down to the actual, let's say, technical business mix of the requirements? So, low cost. I mean, I haven't met a customer who would say, I don't care how much the device is, or who would say, doesn't matter, it's more expensive, whatever. No, it's always the low cost, right? So if you want to make the business case positive, it very often fails on the device cost. So the devices need to be really, really cheap. What makes devices expensive is battery very often, but in this case we still need a long battery life, because the next requirement is minimal operational efforts. We don't want to change the batteries. We don't want to recharge the devices. They should basically be built in and maybe after 5 years exchanged completely or sold with the car. Yeah? So you build it into the RV is used for or rented for 5 years, and then it's sold. In this time, you don't want to touch the device. You just want it to be there, because any manipulation you need to do with the device, it's a human cost, and that basically breaks the whole business case. there must be a security. There must be some security. We don't. So don't take me wrong. This presentation is not about compromising on security. This presentation is about adequate security for the use case. In this case, yeah, what can happen if somebody can interrupt the data, or if somebody can read the data? Well, he will know where we park our RVs, but I mean, he can come and look at them as well and find them. So what we need to avoid is that somebody else is maybe sending the data. Yeah? That somebody else is impersonating our cars and well, screwing up our data. But that's the adequate security. So we have to protect it, but it doesn't have to be a full-blown end-to-end security installation. And we want to have a simple backend so that we don't need to invest too much into the infrastructure like pre-shared key management. Yeah? We just want to have our backend getting the data, displaying it on the map, and not care too much about all the other surrounding supporting things. So again, keeping the backend simple keeps the cost down, makes our business case then positive. So boil down, what are the general then problems that we need to somehow address? So the security, as I said, let's see what is adequate, because security is power hungry. If you have a DTLS connection, it's sometimes 5 to 10 times more power hungry than without the encryption. Yeah? If you have DTLS and you say, okay, I will do the pre-shared key, I will not do the certificates, so I will lower the consumption of the energy, you need to have a pre-shared key infrastructure to manage the pre-shared keys, yeah? Somehow, to make sure that the devices can be authenticated. And also the maintenance of the devices themselves, if you need, I don't know, certificate management. Again, you don't want to do that. Yeah? You don't want to send the people out to do the password changes on the devices or do any manipulation of the devices. But in our case, data is not highly sensitive. So as I said, we can afford if it leaks somewhere. We should not get a false data on a mass scale. Yeah? We don't need a real time, so it's going to be very, very simple in the application itself. I think you already guessed what the radio technology might be here. Yeah, so either narrowband IoT or LTM, something low power. Sure, you can also think about the LoRaWAN, but we are A1 Digital. We do the licensed spectrums for a better stability and quality. And we do that as a service, so you don't need to build an infrastructure. So from my perspective, narrowband IoT would be the technology to use here. But how do we now put on the security on top of this? So I have here the vehicle, a cheap device, narrowband IoT, something with a simple GPS, maybe just a cell-based. I don't know how the coverage is. It could be a cell-based location, or it could be a GPS location. I have a mobile network operator, so A1 Digital, for example. There's a gateway, and then there is an internet connection towards the backend service somewhere. So how do we secure this end-to-end chain, and what features do the mobile networks bring with them? So the first one is the SIM card. The SIM card itself is already a secure element. Yeah? It's a hardware-based secure element with the certificate handling and with the credentials on the SIM card, and we can mutually authenticate the network and the device. So the device knows it's on the right network, the network knows it's the right device. So we already have an identity of the device if it has a SIM card. This identity is somewhere in the network, so just keep it in mind. We have an identity. The second step is the encryption over the air. This comes with the network. So this is one of the things you cannot turn off. It's there. Yeah? So your data is encrypted on the radio interface. The signaling is even encrypted in the network further, but it does not concern our IoT use case. But your data is safe over the air. Yeah? It's encrypted. So it's already one place where an attacker could basically interrupt the traffic without us knowing it because it's on the radio. This one's protected by default. You cannot turn it off. The next part of the network of this end-to-end chain is the mobile network of the operator. I said at the beginning that these mobile networks serve very, very sensitive data for governmental organizations and so on. So the network itself is what we call a trusted network. So I cannot guarantee it's encrypted, but if it's not encrypted, it is definitely under a physical control of the operator. Yeah? Most of the operators, though, today with the LTE, so with the infrastructure for the LTE, they have built an encrypted infrastructure on top of the trusted physical infrastructure. So it is very unlikely that this could be a place where our solution would get compromised. The next feature that the mobile operators offer you is a secure connection between the gateway, so the termination point of the connection, of the mobile connection, and your backend. So it's basically an IPsec tunnel, or you can have a dedicated MPLS physical connection over an MPLS network. But you can protect this, so encrypt the path between the operator and your backend, and we still don't have any encryption on our own, right? So we are completely end-to-end protected without any specific encryption on our device or on our application and backend. And the last part, as I told you, we have this identity here, and we have authenticated against the network. The network knows who we are. And now, for the backend, it seems to be a good idea now to ask the network, actually, who is talking to me. So the network operators and A1 Digital can offer you this kind of an identity relay. So you ask about the IP address that is contacted you, and we can give you the information who is that particular, or which SIM card is in that particular device. So you have a trusted identity coming from the network, and you don't need to do the authentication yourself. Yeah? Or maybe you can use that as a second step of your authentication. So for a simple use case that I have presented you, where the security is not that critical, we can build a chain end-to-end based on the features of the network itself only. And you don't need to consider that in on your application layer. You can save a lot of the energy that is used on the devices for securing the connection, for doing the authentication, doing the handshake for the certificate exchange, and so on. You can also keep your backend simple, because you don't need to take care about the user authentication or the database of the credentials for your devices, and so on. And still, you have an end-to-end encrypted network connection that cannot be compromised. Any question? Is this something new, or is it just a reminder about the things that are already there and you know about them? I guess it's just something that is there, but I really will have a call to action at the end. where I would ask you to read into it, right? To be aware what the network is providing you, but that's something that I will ask you later. And there is more security, which I did not have in my use case, but there are things either already available or coming with the 5G. So these private APNs that I have had there with an IPsec tunnel, you can use them for different other things, like you can have your own, you can ask your network operator to give you your own IP and URL filters on top of the APN, so that you are sure that your devices can only reach a certain destination in the internet, for example. Yeah. Makes it a bit secure against misuse of the SIM card, because we have seen this. Yeah? You see an IoT device somewhere, you take out the SIM card, put it into your phone and use it. If you have a filter there, it's no use for you, right? Or you can separate the traffic. You can use multiple APNs for the telematic and for the entertainment in the car. Yeah? So that's another way how to do the traffic separation using the private APNs. eSIM and specifically SGP32 based SIM cards, which you can manage from the network. You can have multiple profiles on a SIM card and make sure that you always get the connectivity. Even if the network of your primary provider is down, you can switch to the second profile. So you have, again, the security or resiliency as part of the security can be also provided by the network technologies that we have. IoT Safe is a technology that uses the SIM card as a storage for your own certificates. So if you decide to build your own secure infrastructure on top of the mobile network, you can use the SIM card as a hardware element to store your certificates of your application. And then in the 5G, we have a better identity protection, so it's not IMSI anymore, which can be theoretically fetched. And then it's not a big breach, but if you have an IMSI, you can theoretically do a statistical following of a subscriber. So you can try to find him, how he's moving around the network. You cannot breach his data, but his identity in a way. But in the 5G, this is not possible anymore with the subscriber permanent and concealed identities. We will have a slicing functionality to separate the network into multiple quality of service slices, where you can then again ensure that your data gets through. And there will be integrity protection in addition to encryption. So today we have encryption, but theoretically someone can manipulate the data in a way that he doesn't know what he manipulates, but he can kind of destroy it, yeah? Because it will not have the integrity when it comes. In the 5G, the integrity protection is added on top of the encryption, so you will have a completely secure radio interface for your use cases. Good, and now I will finish with a call to actions, basically to summarize what I'm trying to hand over to you. Consider security already in the proof of concept, because it may not be that difficult if you know which parts you are using. So if you know you are using a mobile network radio interface, and you know it's an LTE interface, then you know it's encrypted. So do I need to care about the encryption? Well, maybe I do if it goes into the internet afterwards. But if it goes into an IPsec tunnel that I have built with my mobile operator, maybe I don't need to consider security at all. So know your end-to-end chain. And also ask the operator. Maybe operator can provide you some of these advanced features. Maybe the operator can advise you, or maybe the operator can just help you to kind of fill up your NIST2 requirements, yeah? Because we think about these things, we have that, and we can just give you a formulation about the NIST2 compliancy, and you will just file it into your database, yeah? And For the OEMs, my shout out is give the options to the customer. So let the customer have the option to decide if I want the encryption or if I have it from the. So if I want an encryption and a lower battery life, or if I want to have an encryption from my mobile operator, turn it off on the device and have a longer battery life, for example. So also the manufacturers of the devices are asked here to consider what the different options are, because the more options the customer will have, the more likely their IoT use cases will make will be commercially viable, and the more devices you will sell by the end of the day. So with that, are there any questions from the audience? If not, then thank you very much, and have a nice day here.